Do you know what the sluttiest thing a man can do?
DP obviously stands for dynamic programming. We're going to walk through the natural dynamic programming progression for the LeetCode problem min cost climbing stairs to show you it's really not as hard as you think. We're given an integer array cost where cost I is the cost of the ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps. You start from either the 0 or the first step, and you want to find the minimum cost to reach the top flight. Every single dynamic programming problem can be broken down to a decision tree. In this case, at any I step, you can either take 1 step or 2 steps. So the brute force idea is simple. We're going to try both moves, compute the cost of both, and select the minimum one. Which you'll realize as we go through the stairs, we're recomputing the same thing multiple times. This is the core of dynamic programming. The solution above, in which we try every possible combination, is called the backtracking solution. Whenever you're solving a dynamic programming problem, you should always do this one first. This helps you identify the pattern and the structure for the next step. Specifically, what work here is being repeated. Once we've identified the backtracking solution, it's easy to see the top-down memoization approach. This is addressing the question of, if we already solved this step, why redo it? So we can add a dictionary called memo. Memo isn't fancy. It just stores the results of that step after we've computed it. So that means at each step we encounter, we first check if it's in our memo dictionary, and if it is, we just return the saved result. This is the core of dynamic programming. It's really nothing fancy at all. It's just caching your last recursive result. Before we get to the third option, it's important to note that the third option has no better time complexity, it only has better space complexity. So if you struggle with the next option, being the bottom-up approach, don't worry about it. It has the same time complexity, and odds are in an interview, it probably won't matter. Final optimization, we don't actually need to store all recursive results. Most dynamic programming problems will just depend on the last 2 computations. This allows us to not use recursion at all and do it iteratively. In this example, we start at the end of the list and go backwards, only keeping the values of the 2 future steps. This turns it into a single loop and eliminates the recursive structure. But more importantly, it reduces it to a constant space complexity, only storing 2 values. The real question is, how can you take this example and apply it to all dynamic programming problems? Next time you see a problem that requires dynamic programming, I want you to follow this checklist. 1, define the state. Ask yourself, what question am I solving at each step of the problem? 2, write the backtracking solution first. In an interview, this is good to get your thoughts on paper and get help from your interviewer. And it allows you to identify the recursive relationship and come up with your top-down approach. Lastly, if you're an overachiever, you can look for patterns to compress the memory or rewrite it iteratively. It's your final, fully optimized bottom-up dynamic program. If you start seeing problems this way, DP doesn't become as much of a buzzword as it was before. It's less intimidating, a simple idea, and something you can totally tackle. If you found this video helpful, drop me a follow. I'll see you tomorrow.